Hi, my name is Adarsh Malapaka and I'm a student of the ENPM809T Autonomous Robotics course in the spring semester offered at the University of Maryland College Park. I'm a master's student in the robotics department here, and as a part of this course, I made this robot that's right next to me, and I'll talk about this in a while. The main intention of the course was to be able to practically implement theoretical concepts taught in the robotics course, such as perception, localization, sensor integration, calibration, and filtering, and to see these in action on a real robot as it performs certain tasks. The main aim is to compete in a grand challenge. Now this year's grand challenge is based on planetary exploration and colonization, wherein we have a simulated construction zone going on Mars, and you want this robot to pick up construction materials from certain spaces and place them in other designated areas. And in this zone you have required and unwanted construction materials, and the robot must autonomously decide which ones to choose and which ones to reject, and where to go and pick and how fast it can do this. Now, the map of the arena looks something like this, where this is where the robot starts off. This is called the landing zone, and the robot can start off in any initial position and orientation. And the robot has to go to this zone, which is called the construction zone, which is where the construction material. In our case, we have colored blocks. We have red, green, and blue colored blocks that the robot must pick up and drop. Now these blocks or construction materials are placed, in a random fashion in the cluttered environment. The robot must autonomously drive through this cluttered environment, pick a red block, place it in the construction zone, go back, pick a green one, place it in the construction zone, go back, pick a blue one, and repeat this sequence again and again. Now as it does this, there are also yellow, black, and white unnecessary blocks kept in the environment to simulate unwanted construction materials. So the robot must autonomously perceive its environment and decide which blocks to pick and which ones to reject. Now, to be able to do this, the robot that I have over here has four DC motors. And these DC motors are powered by a rechargeable battery pack. And the heart of this robot is concentrated at the Raspberry Pi 4, which does all the computations, takes in all sensor data, and has a Raspberry Pi camera that's connected to it straight up. Now, for the robot to be able to perceive or sense its surroundings, the robot has first up a SODAR, or an ultrasonic distance sensor that measures distances. It has an inertial measuring unit, or an IMU, to measure the angle or the orientation of the robot. And two wheels on the robot have encoders on them. And using the encoder ticks, the exact location of the robot is determined, or in other words, the robot is localized using the encoders. Now, in addition to those, the robot also has this gripper mechanism, which opens and closes, which enables the robot to pick up a block and place it in a certain place. This is the basic setup of the robot, and the video you will see what went into the making of this robot, how it was tested, what were the challenges faced, and finally the grand challenge run that the robot was subjected to in the end. challenges faced while building, testing, and practicing with this robot are that most of the times the encoders on the wheels were not really accurate because of the low number of encoder ticks per revolution, which made it difficult to localize the robot. So since the localization by the encoders was not dependable, the ultrasonic sensor was used to recalibrate the robot's position by going to a corner point and orienting the robot 90 degrees and 0 degrees and recalibrating its position. A major issue with the robot was when the robot was moving in the arena and there's a block in its path, the robot would push through and the block would just topple or fall over because of the screws on the gripper. To overcome that, these shields out of cardboard were attached, which make the block just slide off if it encountered the block. So the block could be picked up in the next search iteration. Another source of error or another problem with this robot was that the HSV masking to detect colors, red, green, and blue, would sometimes be off from the values that were tuned before due to ambient light conditions or other colored obstacles in the arena. And this was taken care of by tuning these threshold values by placing the block and the robot far apart in multiple different configurations basically.